We're ready for example number 7 of inverses here. We have a function called g of x. We want the mathematical expression that would go in the opposite direction. It doesn't, but play along. If this math expression converts feet into inches, then the one we're about to build would be inches to feet. It's not what it is. It's just a made-up math expression, but you get the idea, just like the Celsius Fahrenheit in opposite directions. That's what inverses do. So here we are. Here's mechanical steps. We're going to change that g of x into the more traditional y equals. All right. And then we will switch the variables. I think I should be writing the word swap here to emphasize that. So x, change y to x, equals 5y over y plus 2. All right, so there you go with that. Now, solving this for y, step 3, would be again those literal equations that we did days gone by. All right, so we clear fractions, which would be to multiply by y plus 2 on both sides. Over 1, it's going to cancel. And so this is 5y. And then over on the left, we would distribute the x. And that'll give us xy plus 2x. Okay, now something very important to remember on this one. In this example, the variable is actually, now remember the variable is y. We're solving for y. And I want to note here that y is in 2 different terms, isn't it? So I hope you recall from assignment number 15 that we want, when the variable is in more than one term, we get all the terms that have y on one side of the equation and all the terms that do not have y on the other, right? So this has y, this has y. I think the best thing to do here would be to subtract this xy term over so it's on the same side as the 5y. We want the y's on the same side. So this, at this point, the equation becomes 2x equals 5y minus xy. Note, these two terms that both have y are on the same side, and this term that doesn't have y is on the other. Oh, that is so assignment 15. All right? And then you hopefully recall that since y is a common factor, you can factor out a y over here on the right-hand side. Boom. And then you go, well, I want y by itself. What's going on between the y and the parentheses? Multiplication. So that was the logic behind going ahead and dividing both sides by the expression that's in the parentheses. And then much like we did on assignment 15, even though we could say math expression equals y, it's more standard to put y equals math expression. Okay, so then that's old stuff, and then back to the current day, then we said, okay, now you could call that f of x, g of x, h of x, whatever, but the mathematicians of the world said, why don't you give this a name that tells the viewer it's the reverse process of the original. So if the original is called g of x, see this y back here was called g of x. This new y that we just created, after we swapped them, should be called g inverse of x, wouldn't it? That tells the viewer that this formula, this math expression, does the reverse process of the one called g. So that's another reason we have functional notation, is so that we would know that relationship between these two expressions. They do the opposite of each other. There you go. All right, 2 more inverses.